Today we're going to be talking about ocular regeneration and tissue engineering. And so this afternoon I'll be interviewing 3 of our young researchers. They've just recently started with us, and they're all working on specific areas that we hope in the short term will start to really lend hope and promise to those who are suffering from vision loss for any reason. People wonder what tissue engineering and ocular regeneration really is. Sometimes an easy way to describe it is if you think about a starfish, it has the ability, if one of its 5 limbs is cut off, it totally regrows that. So we're looking at that. Are we able to develop the tools and the capabilities to regenerate tissue in the human body? Are there ways that we can modify healing so that we end up with a really good result again at the end instead of just scar tissue that is not really functional? So these guys are helping to lead the way in some of this work on ocular regeneration, and I'm excited that we have the opportunity to talk to them. Now I'd like to introduce Dr. Daewon Park, who is another one of our special fellows that's working on ocular regeneration and tissue engineering. And I'd like you to tell us a little bit about you, what got you interested in doing this, and then tell us some about your project.
Okay, thank you. My background is chemical engineer, and most of my research background is related biomaterial. So I have mostly focused on these days nerve regeneration and also drug delivery system. And for this postdoctoral project, I have focused on ocular drug delivery for the treatment of macular degeneration.
Well, that's very, very important because so many patients are intimidated by the treatment that's necessary for macular degeneration. And I'm not sure that because of that concern that they have, that they may be as compliant and have the medication administered as often as they might need. So tell us about how you're going to make that easier for them.
Well, so we firstly should know about macular degeneration. So, right?
That's a great idea.
Yeah. So macular degeneration is kind of eye disease of human eye. So when the people have the macular degeneration, this kind of blurred scene. So let's suppose it's winter time. So you want to make the window in front of your window with a foggy window with blowing warm air.
So we inhale on the window and make it foggy. Okay.
Like right.
Okay.
And can you imagine what can you see through the foggy window? You cannot see through the foggy window. The only thing you can see is the blurred scene through the foggy window. So that's it. So the people who suffer from macular degeneration, they have this kind of foggy scene, blurred scene. So what I want to do is to make the blurred scene wiped out and make it clear for with treatment of macular degeneration. But basically, the current treatment is the direct injection of the drug into the eye. But this system, the drug cannot stay in eye a long period of time because they are washed out very fast by the flow of eye fluid.
So the body cleans the medication.
Right, that's true. So at this point, my question is, can we protect the drug and make it stay longer in eye when they are injected into the eye by single injection, and the release can be controlled for a long period of time and cure the macular degeneration.
So ideally then you would reduce the frequency of those eye injections because the medication would be protected and sustained inside the eye longer. How do you think you'll do that?
So as I said, the project is to make the drug stay a long period of time. So I made this kind of material. So would you help me with this? So you may want to grip on the top part. Yeah, this part. Okay. And then would you tell us what's it like? Okay.
It's a clear It almost looks like water. It runs
Right.
smoothly up and down the vial like water.
Right, right. And then would you hold it and warm it up during my talk?
Okay.
Yeah, okay. Thank you.
I'll sit here and warm this up.
Okay. Yeah, so this material is interesting. So basically, it's water soluble, like salt and sugar. So before I came here, I took some of the material and dissolved in water and make a solution.
Okay.
And here's the cool thing. So when this solution is warmed up, then it becomes viscous. And when it is warmed up more, like human body temperature, it becomes gel.
Okay.
And the question is, what can you do with this material? So we will simply mix this material with drug and then inject into the eye. And the mixture, when the mixture are injected in the eye, then the mixture will be gel. So the drug will be entrapped in the gel, and in this state, the drug in the gel will be protected by the eye fluid, and the drug will be released very slowly from the gel. So the treatment effect can be controlled and stay longer in long period of time by single injection. So yeah, now we can check the gel what happened to it.
Oh my goodness. It's moving very, very slowly now. I was afraid my hands would be too cold. Cold hands warm hearts, but
yeah, that state is viscous. So when you warm them more, then it becomes a gel totally.
wow, that's fabulous. And so then that would decrease the frequency of those injections
Right.
potentially by a couple of months.
Right, that's true.
Well, I know that the patients would look forward to
Right.
that opportunity.
Yeah, so
that
currently,
opportunity.
currently patients should see the doctor these days every 2 or 3 weeks for treatment. But when it comes to true, then the treatment period will be 3 months or 6 months. Hopefully.
Okay. And so this will require preclinical trials as well.
Right.
But because the medication is already approved, will this require FDA approval? Will we have to go through a special clinical trial with the FDA's guidance to ensure that it remains safe for patients?
Yeah, sure. Basically, the drug itself approved by FDA, but the problem is our material, this material. So
Okay.
we have to get approval by FDA. So I think we have basically 2 terms, long term and short term.
Okay.
So the short term will be the laboratory based experiment, and long term will be practical use after approval of FDA.
Okay. So it's on the horizon. But
Right.
again, because of the time length to go through those trials with the FDA, it's
Right.
still several years out then.
Right.
Okay. Well, wonderful. Thank you very much.
Thank you very much.